Errors and exceptions in Python. Today we'll talk about syntax errors, exceptions, error and exception messages, and about inbuilt exceptions. Speaking in any language, there are rules to follow. A programming language has a syntax to stick to, and when you bend a rule, you commit a syntax error or say a parsing error. If 3 is greater than 1, print hello. Let's see what this gives us. A syntax error when it reaches print. There are 3 problems here. The lack of colon after the condition, the lack of parenthesis in the call to print, and that we put double quotes before the string hello but ended it with a single quote. But it halts at the first one and declares it a syntax error. Exceptions are different. They are errors detected at runtime, during execution, and may even be fatal. This code is perfectly fine syntactically and will even work fine with most values, but the moment b is 0, the denominator is 0, it means dividing by 0. And since that's not possible and the program doesn't know what to do, it raises a 0 division error and your program halts at this point. No code after this is executed. An exception is Python's way of telling you something has gone wrong. It throws out 4 red lines in your face while providing a useful traceback to what caused the exception. This code raises a 0 division error. The exception is traced back to its source, the exception generated at line 1. PyShell #12 means we're running Python in the shell, and this is our 12th statement so far in this session. This is the culprit. This is the statement that raised the exception. And this is the exception that occurred. What happened is that we tried to divide by 0, and so it raised a 0 division error. So like functions and such, exceptions can be built in, and we can also create our own. Let's talk about some built-in exceptions and how to wittingly run into them. We've learned about asserts. When an assert statement isn't true, it's false, and this raises an assertion error. This is false. 1 is not equal to 2. So this raises an assertion error. This is an exception, and one with a full traceback. When we try to refer to an attribute that doesn't exist, it raises an attribute error. This class fruit does not have the attribute color, and this empty list does not have the attribute sort. It gives out a traceback, but for the next few examples, let's focus on the type of exception and what raises it. The input function takes in input from the user. When a call to this reaches the end of file condition without reading any data, this is an EOF error. And when something goes wrong with a floating point operation, a floating point error is raised. While it's always defined, you'll need to turn it on with the fpectl module. This is the floating point exception control. When the close method is called on a generator, it raises the generator exit exception. This helps it terminate iteration. When you try to import a module that doesn't exist, or even a function that doesn't exist in the module you're importing it from, it raises an import error. Importing square from the math module does not make sense. Sometimes making an import may cause an exception if it fails in loading a DLL. In this case, importing sklearn, importing pandas first may resolve this issue. Index error raises when you access a sequence, like a list, at an index that does not exist. Here the indices are 0 to 2. There's no index 3. When you try to access the value for a key that does not exist in the dictionary, it raises a key error. The key 2 is not a part of this dictionary. And for the times you have yourselves an infinite loop, you can break out of it by pressing Ctrl and C together. This raises a keyboard interrupt. When running an operation, if Python runs out of memory to hold the temporary results and keep everything going, it raises a memory error. And when a module cannot be located, we have a module not found error. This is, of course, a subclass of import error. And if you access the value of cheese, but you haven't defined it in this scope, this raises a name error. If you haven't defined an abstract method, this raises a not implemented error. And when a system operation causes a system-related error, it raises an OS error. This exponentiation has a result that's too large to be represented, so it raises an overflow error. And when a weak reference proxy tries to access a garbage collected referent, it raises a reference error. When an exception is raised and it doesn't fall under any specific categories, you have a runtime error. When an iterator has nothing else to return, it raises a stop iteration. Issues with indentation cause an indentation error. And when you've inconsistently used tabs and spaces to indent, it is a tab error. And when the interpreter detects an internal error, it is a system error. The exit method of the sys module raises system exit. And when we try to operate on two incompatible objects, like when we add an integer to a string, we raise a type error. If we try to access a variable without ever assigning to it first, like we do here, it raises an unbound local error. When you run into issues when encoding or decoding Unicode strings, it is a Unicode error. During encoding, it is a Unicode encode error, and when decoding, it's a Unicode decode error. And when translating, it's a Unicode translate error. If you use an argument of the correct type but with an incompatible value, it raises a value error. And of course, dividing by 0 raises a zero division error. These were some built-in exceptions in Python. Let's learn to handle them and also create our own exceptions next.